Welcome to part 6. First of all, this is at 4K because I was actually working on the game. Game, so to speak. So we're gonna have a quick run around. All I'm doing is hitting the forward key on the keyboard, and that was an adjustment with the side key. I missed a jump. So as you can see, the level was all corrected. It all has materials, and there were a few things added for style and stuff I did not bother filming because it's usually boring and tedious. That particularly right there. And that camera was adjusted as well, along with a listing of what's what. So, in part 6 we're going to cover all of the changes that were made to the blueprints. First of all, folder structure. We have repositioned some of the stuff inside inside of the demo map. Mostly the geometry and the mannequin third person. It's just standard to kind of keep a decent layout of things so that users can then find whatever they're looking for a lot easier. In terms of the actual game map, we have this new information here that explains to somebody just running the game what things might be. If you went through the YouTube tutorial, you have no need for that. Let's take a look at things starting by the interface. So we have the functions here again. External camera, which has a camera actor. Internal camera, which has a camera actor and a camera ID integer. Get camera ID, which returns a camera ID. And dynamic external to get the dynamic camera, which returns dynamic external. That's our we haven't changed anything out of that. Then let's take a look at the camera operations. This is the bulk really of the whole system. We have a function implemented from the user interface here for the control rotation. We modified these functions in the previous video to prevent the rotation from taking place if the control takeover variable is enabled. This code may end up having been repositioned a little bit, but it's mostly just the same. It's the same function, and you have put the different rotation based on whether you want to or not. The interfaces. So for the return nodes, get dynamic camera just returns. This one just returns, and then you have the internal camera and external camera, which are implemented up here in the graph. Let me close all of those out so that we can go one by one. So for the event internal camera, right? We call this event. Whenever we call this event, we check the camera ID. We check the camera ID and we set it to -1 if this ID coming in is -1. We select the old camera ID, so there is no change. Then we have a select float here that selects the view target with blend based on information of what is available, basically. If we have an internal camera that was able to be set, otherwise we transition. This should enable us to pop this component inside any character, whether they have a custom camera or not. So this portion here sets the visibility of the head mesh, and it was moved here and timed according to the 0.4 is the time of the variable, but it does not prevent the other functions from taking place necessarily. So when the visibility is set, yes, there will be a delay before it transitions onto the external camera. However, for all the other ones, it's bypassed entirely so that the delay node is not part of it. And then let's take a look at the external camera event, getting to the external camera. So when we do that, we just set the external camera and we do that. We do the visibility check, which is a bit of a reverse of the one before. If you remember, we used the component tag to find the component. We check whether it's valid or not. We check that we're in first person, and if we are in first person, we set the visibility. This used to be toggle, it now became set visibility. This one is checked. The other one down here is not checked. Then we just get the player controller and switch to the camera and flag the dynamic external variable. The dynamic external variable is also at the end of the other pathway, so that we keep track of that. Then we have the event tick for this, for the character, basically. So on event tick, we're checking that the external camera is valid. Is not valid, rather. When the camera is not valid, then we check. So we're not looking through an external camera. We check the character spring arm. The spring arm is collected here in the event begin play. That hasn't changed. We did change a few things here. We started to prevent the camera from taking over when moving. So if you have a velocity that is greater than 3, this whole event will not trigger. This made it possible to stop some issues where they weren't bugs as much as just bad behavior. If you were running against a wall, you would get the camera to transition, and if the control takes over, you start running the wrong way. So we wanted to prevent that. So here we check the external camera, and we try to launch the external camera. The launch of the external camera again is preceded by a 0.2 second delay, and then we get the control rotation of the character. We get we basically just generate where the line starts and ends. We've gone through that. I don't think that code has changed. Here we do the rotation check to spawn the camera. We flag dynamic external, and we set the options for the camera. We disable head-on change for this camera. I'm still not sure about this. I think I might flag it to be the other way around in the final release. I have to try playing with it some more. So we covered that. We covered this. So we're good here. Let's go into the character camera. So let's close everything out. The character camera hasn't changed since the beginning. So we have just the event graph with event begin play. And on event begin play, we decide whether or not to auto-possess. If we auto-possess, we set the internal camera. We have the construction script. This one sets up the variables for our camera. That's it for the camera, really. For the player camera, character camera. So external camera instead is the complicated one, and this one did get refactored a bit. First of all, the event graph is entirely empty. I actually moved all the functions out and named the graphs themselves to what they are. Whoops. So let's go over them, right? The construction script. To the construction script, we added a actor location for the camera and a camera rotation for the camera. This will be used by the new function that I do not believe was introduced. I'm not sure if it was or not in the older in number 5. That allows the camera to follow the character, like rotate towards the character. We have a bunch of variables here inside management that allow us to control the camera. You can pause the video, and just watch through that, but we'll walk them through them anyway. We have the event tick, which takes care of pretty much everything that happens, including the slow-mo, including everything else. Well, actually, no, the slow-mo is done beforehand. But so we prevent the access to the event based on a boolean. If this boolean is true, then we access the event. We check if this actor is being destroyed. We checked if the overlapped actor is available. If it is not, it's not valid for whatever reason, we double check that the cone has something colliding with it and that it is active. If these conditions are true, then we manually end the overlap event, which prevents errors from generating or cameras from being left after they were spawned manually. We have a follow actor option, which was introduced. So if this is false, we just bypasses and go wherever else. Otherwise, we just take the look at rotation between the camera and the character, and we just set our rotation to that so that we are looking at the character over time, because this is happening during the thick event. We check if the overlap component is existing or not, and again we check if the overlapped actor is valid. This was introduced and it is necessary. Sometimes you would get to hear this actor component would be valid, but overlapped actor had been deleted. So we check that the output of this is valid, and this just gets the reference to the AC camera operations. So we have the actor component, which is the AC camera operations. We memorize it if it is valid. If it is not valid, we check again. And then we had to do a little bit of work around here to get the variable. So we had to cast to the camera operations, and I chose to do it with an actual cast so that I could use the pin. And if this value was not true, then we act accordingly. We end the overlap, and there's a new value here to allow the first person transition, which is what this was done for essentially. So if I'm in first person, I want to either be able to for the camera to be possessed or not, and I shouldn't say possessed. I should just it's not a possession thing going on. So at the end of all of this, we just call the external camera by passing ourselves to it. That's the event tick in its completeness. So we have the overlap start and the overlap end. Let's start with the start. So on start, are we already using a dynamic camera? If that's not true, do we allow for the head-on change to occur? If that is true, we do some angular math, and if it checks out, we proceed. Otherwise, we die. If that wasn't true, we just keep going like the old pathway. There is a 0.2 delay between the activation of the camera over here as well. And then at the very last step, we do the time dilation setup. If the time dilation does not equal 1, we set the time dilation to whatever we set. Okay, so that's the start. Then we have the end. Overlap end. And by the way, yeah, this one has 2 because of the manual end overlap. So the manual end overlap was moved, and we'll get to that. So when the event starts, we check if the actor is being destroyed out of paranoia. And mostly because I was getting errors, like I mentioned in previous tutorials, because of the cone. We memorize that we check if the actor is correct. If it is, it is the one that we already had, and it's not a new one that came in or went out for some reason, like you threw a grenade, something like that. We do the information here to get components interface. We use the get camera ID actually, which I did not remember us using. And then we set active to false. We're doing this manually. So we set the we call the internal camera blueprint interface, and then after that we overlap. We reset the variable to 0. We reset the time dilation. We destroy the camera, and as a branch, if we do not allow the camera to be destroyed, so this is for all the cameras that are not, we reset the follow actor. You notice that the following actor is reset after 1 second of a delay, and that is by design, because when the control switches back and forth, if you don't have a delay here, you get really weird effects with the rotation of the camera going back to its original position and the transition to the actor with the view blend, so the camera is like twisted. For the manual overlap, we moved it away. It was somewhere over here, I think. And we took it out and made a manual call with a -1 value. As if you remember, I explained that what this does earlier. And then we just pipe in after the same event with the actual camera ID has been passed in. This was the final bit to resolving the issues that would prevent the plugin from being added on to the marketplace with errors. So then we have the test hero. Now the test hero had a major change, if you will. So this is the original code, and this is the code I'm using. The code I'm using does not rely on you having the input information, because most projects usually have their own keys, and you don't mess with that anyway, because when you create the marketplace asset, it does not import your settings. So to test it, I just deleted the input settings and made sure that that's working anyway. The mouse wheel axis here allows us to flip the camera between first person and third person. Nothing here has really changed. The process that changed is inside the internal camera call. Whoop. I did not mean to click that. Like you saw with the -1, well, there is no -1 here, but you get the point. The process happens in there as well. Additionally to that, I think that remember pass over the construction script again. So the construction script has the set master pose component to keep the head paired to the mesh. Then we have the spring arm. For the first person, it is an inverted spring arm, and it has a gameplay tag somewhere. Maybe it's not. Okay, this one does. The third person has a gameplay tag. The head itself has a gameplay tag. That's how we're getting the information throughout the code. Where are you? There. So the head has a gameplay tag. The camera boom has a gameplay tag. The cameras are set pretty normally, like we left them. I mean, auto possess, and the other one is set to not be auto possessed. It also has a camera ID assigned to it that was exposed, so that this one is 1, this one is 0. And I think that covers the hero entirely. Trying to see if there's any else in the event graph that I should worry about. Okay, so then we have a very simple script for an automated rotation. So on event begin play, we memorize the control pawn, and on event tick, we set the rotation of the object to look at the player pawn. And what this is the logo that I quickly whipped up for. Hey, look, that end does not have a default material. Wrong button, obviously. Material instance crop. Good. Save that. Perfect. Okay, so as I was saying, this is just a quick messy logo I threw up, literally, because it looks like throw up, for the system to have just some, something. I need something to publish to the marketplace. This all works with a base color material, which I've made available in the plugin itself, so I might as well review it over here. We have a scale for the UV coordinates. We have the albedo, which is a variable you can set. Are we using the texture? Yes or no. If we are, you use the texture. If you're not, you use the base color. It's pretty much the same pathway with everything else. We have the same scaling for all the maps. We have a packed texture here that I'm using, out of which it's also labeled so you know what they are. I don't need to go through and read it. And then we have the use texture parameter being used to switch between the texture and not texture. This one should probably be renamed, because I might want to use a texture and use a one metallic. Okay. Yeah, compiling times. Okay, so then we have the is metallic. If it's true, we're basically using the 1. If it's false, we use it 0. Use specular map. The G is the specular map. Use the roughness. The R is the roughness. Use the alpha. The A is the alpha. And for the metal, we use B. Are you on emissive material? If you are, you use the texture. I might need to prevent the base color in case the emissive is true. I'm not sure, but I don't use that. It was just so I shouldn't, I just put this in there for completeness. And then we have the normal map. It's just either an actual normal map or a 001. We can actually do that here, and this just connects to the normal. That's it. It generates the base material that you saw being chrome earlier, or the red and the blue, and you can make a whole variety of colors based just on this. I believe that covers it. Now let's have a look at the in-game features. So when I go into one of the cameras, what options do I now get? So I can check whether it is dynamic. I can offset the cone, which is actually used extensively in some cases. You can see I have all sorts of measures here, including a FOV change, so that the camera looks better. And then the different options to allow the transitions, just like we built during the tutorial. The only one being different now is the follow actor being new. And what that does is, if I run through the event like you saw at the beginning, you get to a point where this camera coming up at the jump actually looks at you. See how the camera moves? So that's what that does. And this one does it too, except for the placement of the cone is so short that it does not follow you. And it's kind of by design, because if I go like this and put the camera over here, you can see that the cone is going to follow you everywhere. So the least amount of time it follows you, the better. And decoupling the settings like they are makes it so that it does not follow you everywhere when you just bump into it. So then I think yes, I have a different camera that follows you over here. It's a little more interesting and lets you understand how it really works. It's just following the rotation of the character, just like you would in any third-person game kind of thing. And then the last thing that I haven't checked in a while is going to be the first-person transitions. They're for the most part allowed, because I don't really use the first person to run around in a third-person game. But when they take over, everything still works exactly as it does, and you also know where they don't take over. It's a good debug tool, I suppose. Obviously, going from first person to third person on moving shots is not as good as it is. I'm not sure that there is anything that can be done about that. That's just the camera location transitioning between one place and the other. The follow camera is much more effective at that. Alright, that completes, I believe, the whole tutorial series. Holy moly, I'm inside the camera. Okay. What else? Yeah, I mean, that's it. You can find some meshes in here that have been created with Blender. The box brushes that were used here have been converted, because that's what you need to do to be able to publish. And That's it.